Did someone say the first derivative test? We want to go ahead and find the first derivative, which is equal to 3x squared plus 2x minus x. Our first step is to set this equal to 0 because we want to solve for our critical values. Here we get x equals -1 and x equals 0.33. We can plug in our critical values and we want to take test points from every interval. Here we're going to plug them into our first derivative because if they're positive or negative, that tells us if our function is increasing or decreasing. So we can see here in our first interval we got a positive value, which tells us our function is increasing. Let's take a look at the graph. We can see that our first derivative is above the x-axis, which means it's positive, and that tells us that our function is increasing. Now on our second interval, we got a negative value, which tells us our function is decreasing. If we check that out with our graph, we can see that our first derivative is below the x-axis, which means it's negative. Now finally, we have that on the last interval, we got a positive value, which tells us our function is increasing. And if we look at our graph, we can see our first derivative is above the x-axis, meaning it's positive. If we were to write this out all officially, we have g of x is increasing on negative infinity to -1 union 0.33 to infinity, and g of x is decreasing on -1 to 0.33. G of x also has a local maximum at x equals -1 and a local minimum at x equals 0.33. So that's how we can use the first derivative test.